Okay, so the general idea is that I'm going to be making this eventually into some sort of self-driving vehicle. But first of all, I'll start with a simple PID controller where we have these two distance sensors, ultrasonic distance sensors, providing the error signal, which will then be interpreted by this Arduino module, and from there we'll be able to devise a controller to keep this moving in a straight line. Alright, I've put in all the pins barring the power and ground cables, and I have a 7.4 volt LiPo battery to power the whole assembly. And now onto the code. Okay, I'm using the new ping library to control the ultrasonic sensors. So first of all, I just wanted to test and see if they're working. And we have the code here. This is the new ping class, which I've just called two class objects, or created two class objects, two sonar objects. I've initialized the pins, and now I'm just printing the distances generated by the sensors out to the serial monitor. And here we have it. And the pins are changing as the distance is changing as I move my hand further away from the sensors, and it seems to be working just fine. Okay, what I've added in this instance is I've imported the MPU6050 library to run the gyroscope. And the MPU6050 gyroscope. I've created some constant values for the PID controller and for the gyroscope values. Here we initialize the gyroscope. We calibrate the gyroscope. We set the threshold. You can look up the MPU6050 library to find out more on what this does. Then we go into the main programming loop where we have the set point set to 0, and then we import the gyroscope values as a vector norm. Then we just extract the yaw values, and the reason why we have the yaw values will become apparent later. Why I'm using the yaw value will become apparent later. But for now, I just want to focus on the PID implementation. So we have the error signal that was calculated in the last extract, being fed into this PID, this instance of the PID of a PID method that I created. Then if we go down in here, we have a simple error method which calculates the error, and we have the PID method. So in this method, what the PID controller is just simply multiplying the error value or multiplying certain manipulations of the error value by constant values to give us an output controller value, which can then be used to drive actuators and motors. So the P gain value is simply the error value multiplied by a gain constant, which is denoted as Kp here. Then the integral value is simply the sum total of all the errors multiplied by another gain constant value, and the derivative term is just simply the current error minus the previous error multiplied by gain constant value. And these three values are then summed up and returned into these double constant values, which can then be used to drive the motor actuators.